Okay, now let's start our discussion with quality factor. Now, quality factor is actually means the sharpness of the response of our filter across its center frequency or resonant frequency. It is the sharpness. Okay, so what does it actually means that this was my center frequency FR. Okay, so you can see the quality factor is equals to FR divided by bandwidth. Bandwidth is my difference between my high frequency and low frequency side. Okay, so that actually means is that, so what it actually means that if I have a very low bandwidth, I have a very high quality factor. Okay, so what does it mean by very low bandwidth? So if you see, low bandwidth means my signal is like this. Okay, my signal is like this, so I have a very small bandwidth here. So very small bandwidth means I have a very high quality factor. Okay, what it actually means is that I am allowing a very certain range of frequency to pass. Okay, I am allowing a very certain range of frequency, so it has a better quality factor. Okay, now oppositely, if I have like a very, let's make it black. Okay, if I have a high bandwidth, okay, my quality factor is very low. Okay, the high bandwidth actually means I have, this is like, so let's do another figure. Let's do another figure. If this is my figure, high bandwidth, that means I have a very large band pass. I am allowing a very large portion to pass. Okay, so this has a low quality factor. Now this has a special name. This one we call it wide band, and this one, this red one, we call it narrow band. Okay, so uh, one is my wide band BPF, and the another one is my narrowband BPF. Okay, narrowband BPF. Okay, this which type of bandpass filter we want, it actually depends on the application. You are not actually familiar with these applications yet. Some of them are like in the telecommunication side and so on, so you will learn them gradually. Now I think this is okay for now. So this is our discussion of band pass filter. Now there is another one, the fourth one, that was the band stop filter. Okay, now band stop filter is actually quite the opposite of band pass filter. So let's remove these portions. Okay, let's remove this portion. Okay, now okay, now previously when we actually designed our band pass filter, okay, now we wanted to pass this portion like this. Uh, so we wanted the curve like this. Okay, we wanted only this portion to pass, and we close this portion. We don't want this portion, only this was my pass band. But when we are actually want to design a band stop filter, it is actually the opposite. We want this one to pass, come on. Okay, we want this portion to pass, we want to stop this portion, and we allow again the high portion. So we will allow the low pass portion, we'll allow the high pass portion, but in the middle we want a stop band here, we want the stop band here. Okay, this is what we call a band stop filter. Okay, band stop, we are stopping a particular band. Okay, so previously when we actually design a band pass filter, we connected first a high pass filter. Okay, then we connected in series with a low pass filter. Okay, so when we are actually designing say a band stop filter, okay, so come on, I am designing a band stop filter. Okay, band stop filter. Okay, so what we'll do, we'll also connect a high pass filter, low pass filter, but in parallel. Okay, previously we did that in series, so first we get one output, then crop out the other portion, but now we have a parallel high pass filter and low pass filter. Okay, so then we can get this kind of output. So if this is my okay, let's do it in our PSpice. So this is my circuit for band stop filter or band reject filter, and you can see this is my input. Okay, I have one resistor, one capacitor, one resistor, one capacitor, 3 branch. So we call it actually a 20 notch filter. Okay, notch filter, we call it 20, okay, a 20 notch filter. Now notch filter is a kind of band stop filter or band reject filter which has a very sharp, okay, very selective portion, and very small portion is stopped. Okay, we call it notch filter. Okay, so notch filter means very highly selective. Okay, this notch filter actually means highly selective, highly selective. Okay, it selects only a small portion of band. Okay, so if we actually look at the circuit and look at the output of the network, okay, so we get something like this. Here we have an input, and now it is actually gradually decaying. Okay, then again increasing. So this is our stop band, this is our pass band. So this was our input. Initially I am allowing this portion, whole portion to pass, I am allowing this portion to pass, I am just stopping this portion. Okay, and very sharply. So that is what we call a notch filter. Okay, now similarly, like the previous one, notch filter also have a quality factor. Okay, the term we actually defined previously. The quality factor. Okay, now the quality factor for a band stop filter is actually opposite to what was for band pass filter. So here I have bandwidth. Okay, here I have bandwidth divided by the f null. Okay, null means this portion, the center portion, we call it f null. Here you can see, so this is my f null frequency. Okay, so now as you can see, so similarly, when you have a very high quality factor, okay, your f null will be very small. That means it will be like very sharply approximate to zero, very closely very close to zero. Okay, so that is my concept of quality factor. Okay, so I hope it is clear now. So now try to look at this figure. This is the figure of a notch filter. Here you can see there is some resistance and capacitance value selective. This is twice R, this is R, this is twice C, this is C. So if we actually design like this way, we didn't design in the previously. If we design like this way, twice R, I make that 2K and this is 1K, we'll get a much better response. As you can see, I have a much better, much sharper frequency response. Okay, now you can understand from this that notch filter or band stop filter is very important in our electrical engineering, because we can very selectively crop a portion of the frequency. Very selectively I can actually cut out a portion of the frequency. So this is very important. Okay, so we have actually discussed two types of band stop filter. Okay, this band stop filter, I said two names. One was my band reject. Okay, band reject filter, band reject filter. The other one was my notch filter. Okay, notch filter. So previously in the band pass filter I had said two things. One was wide band, if you remember, and another was narrow band. Okay, so this band reject filter, so this is actually my wide band. Okay, and when I have very narrow band, very sharp, we call it notch filter. Okay, so I hope it is clear. Now again in the 20 and 20 circuit here, I can add an op amp here, so to get some gain, to add some gain to my circuit. Okay, to add some gain to my filter. So okay, this is done.